This video is for creative types who are tired of being trapped in their house with the pandemic going on, but they are anxious to do something productive with their time. In the video, I'll demonstrate how to build an aluminum track nose using the simplest of tools, because I realize that your access may be very limited, as mine was. So if the idea of making this using something like this, or better yet, something like this, sounds appealing, please keep watching. My model for this project is based on a Speedway Motors fiberglass track nose. Speedway is an outfit in Nebraska that sells hot rod parts and restoration parts, and I purchased this a while back for students to build their own versions of in different materials, and I added a special front to it to accommodate this Curtis Craft track nose. We had an original Curtis Craft grill in the shop for a while, and so some students cast that grill shell, and so I built a Bondo sculpture on the front of that fiberglass track nose to accommodate this grill. It's worked really well as a buck. Throughout the project, I'll be using the simplest of tools, and I'm building it so that no welding will be required. I've set out a few rivet seams so that this can be put together with rivets and still be functional and hopefully attractive. I'm going to start with the top panel. It has quite a bit of shape to it. I'll spend the most time on this panel to explain the processes, and the other panels will probably be very similar in the way that they are shaped. I begin with a paper pattern. I'm using gift wrap paper because that's all I happen to have at home. I normally would use a banner paper or freezer paper using the paper side up. Those work real well. This seems like it's going to be okay. Maybe the happy pattern will lift everyone's spirits during the pandemic. It's really important when shaping metal that the piece that you're shaping is always in the same place when you're checking it on the model. And so to that end, I have made a little fence along the back of my fiberglass model so that my paper pattern is referenced to that. There's a center line. And then my piece of metal, because it's referenced to the paper, will also match the guide. So every time I'm shaping, no matter how ugly the metal gets, I should always be able to get it back in the same place because I have this guide. That makes it a lot easier and a lot faster to work. The guide has been notched out on the edges, so it makes it easy to vice grip to my model. I curved this just because I tend to overdo it on stuff. I could have just left a straight 90 along the back and that would have been fine too, but I don't know. I tend to be over thorough sometimes. I'll demonstrate how a person could do this if they don't have a stretching tool. You can also do it with a hammer. I've made just a few cuts in the paper that indicate, as I overlap them, they indicate extra material along the edges that will need to be shrunk. So I'll go through that process in a minute. I'm sure that I will also stretch the middle, although there's not a convenient way to represent that on the paper. I'll be hammering this into a soft surface to make it thinner and longer, and the end goal being that the piece of metal will drape over the metal. The shrinking that will take place on the edges means that these will be getting shorter and thicker, and hopefully by the time it's all done, the paper will fit the model, and then the sheet metal will also fit as represented here with the paper pattern. If you wanted to curve a 90-degree piece of metal like this and you didn't happen to have the hand-operated shrinking tool that is so common, I'll show a picture of that later. You can also do it with a hammer. All you need is a hammer with a long footprint. Even something like this sledgehammer would work. It doesn't have to be a big hammer. The reason that this works so well is the long skinny footprint is going to distribute metal laterally, basically much more in this direction than in this direction. And so when you apply that perpendicular to the edge, this leg is going to get longer and the piece will curve. I've got a couple of other versions of this hammer. Metal workers or jewelers call this a two-way stretching hammer because one is vertically oriented, the other one is horizontal, but that's just one version. Here's a little bit bigger version of the same idea, long skinny footprint. When I hit this piece of metal perpendicular to the edge, it will make this thinner and longer and will curve this flange. Some material choices for a project like this. You would prefer to work with one of these alloys. 1100 is just pure aluminum. 3003 is aluminum with manganese. Sheet aluminum is very common in this alloy. It's really nice for fabrication. It welds beautifully. It's really easy to shape. It work hardens in a good way that makes it stiff for your finished project, and yet you can anneal it and make it soft. The thicknesses that you want to work with are going to be in the 50 thousandths to 63 thousandths range. 50 thousandths is about like your Shelby Cobra. 63 is certainly a workable thickness. It'll be reasonably stiff when you're done with it, but it's not too hard to shape. If you work with material much thicker than that, it'll be a lot harder to shape with hand tools. These are 4 other alloy families that I would try to avoid if you can. They're going to be a lot harder to work with. Some of their, well, basically the heat treatable alloys, I would save those for other projects until you know more about it. Stick with one of these guys for ease of working for now. When we get new aluminum in a sheet form, it's typically in a half hard state. That's what this is. This is nice when you're trying to make, say, a 20s or 30s automobile hood that's supposed to be stiff and flat. You have the option of working it and making it stiffer, or you could anneal it and make it softer, which is what we're going to do. The way that you can anneal this material and make it softer is to heat it up, but you need to know how much to heat it. And so some options for that annealing process I've listed down at the bottom. You can color your material with Sharpie. I like the Magnum Sharpie because it's a Magnum. It has a really large chisel point. You don't have to use the Magnum, of course. It just goes much faster with the large tip on there, and you just cover your workpiece with that Sharpie and burn it off. The Sharpie burns off at 600 degrees. I've tested it. That will be adequately soft for working. Another commonly used method is to cover the material with acetylene soot and burn that off. It burns off at 800 degrees. The metal will be a little bit softer than the Sharpie method, but the there is some risk involved because the aluminum itself starts to melt around 1200 degrees, so it's pretty easy to go overboard if you've not done that before. If you don't happen to have an oxyacetylene torch, you can still use a MAP gas cylinder like this. You can identify MAP gas by the yellow color of the cylinder. After you've coated your workpiece with your Sharpie, you can just start on one side and work your way across. I'm just going to do a small area just to demonstrate what you're looking for. But as long as you just heat the panel evenly, start on one side and just work your way across, that Sharpie will burn off, and by the time you get to the other side, the piece will be annealed. You can quench the workpiece if you want to. It's not going to hurt anything at all on this alloy. It might make it even a little softer if you can quench it in a hurry when it's hot. In my experience, the MAP gas doesn't get it hot enough to really have to worry about burning the material in the way that an oxyacetylene torch most definitely can. And you don't have to chase out every last little bit of Sharpie evidence. As long as you're getting most of the Sharpie burned off, that material is going to be soft and a lot workable. And we'll have to do this several times through the process depending on how much work you're putting into the panel. Every time you do this, it removes most of the evidence of your work hardening, and therefore the panel gets softer and easier to work. I've got it in an upright position on the table because these cylinders seem to want to blow themselves out when you tip them over, and so it just seems to work better vertically. But you can see how the Sharpie has burned off there. So you just want to do that to the whole piece. It'll take a little while, but it's definitely worth it for the labor saved. If you have access to an oxyacetylene torch and you have not annealed aluminum before, you simply light the pure acetylene flame. The process is going to go faster with a rosebud tip, a heating tip, as opposed to a welding tip. Rosebud tips look like this. They're just large and meant for heating large areas. Cover the panel lightly with acetylene soot. The soot is simply a temperature indicator. It's you're not adding anything to the metal, certainly. It's just that we know it burns off at 800 degrees, and so that is a convenient temperature indicator. You want a light coating, as evidenced through here. You really don't want it to get too thick, as in this area there. If it's too thick, it's going to be really easy to overheat the piece and melt it. So if you get it too thick in an area, just take a paper towel and just dab it like so. Pretend like you're an interior decorator doing some kind of faux finish, and that will work for a duck hunter camouflaging a duck blind, and that will do a nice job of breaking up that really dense layer of soot. I'll show just a little bit of that in case somebody is not familiar with how that process works. Here are some options you'll have for cutting your materials at home. You could use a cutoff wheel, either electric or pneumatic. These work acceptably. Just run a tape line on the line that you want to cut. I would definitely leave it a little big. They're going to be pretty rough cuts, like you cut it with a hammer or something like that. And you'll want to leave probably a 1/4 inch extra. And if you do that, you'll be able to do a really nice second cut with a pair of aviation snips. The ones that you'll come across most commonly are they'll have colored handles, and the color indicates which way the scrap is thrown off to the side when you make a cut. The yellow version cuts in a straight line. The idea is that it curls up in front of you or underneath. I would not use the yellow ones unless you have some pretty scary toenails that need trimming or something like that. I definitely wouldn't use those on sheet metal very often. They just don't seem to curl up effectively with the gauges that you are normally working with. On something really light like duct work, they might work okay, but in car work I would avoid the yellow ones. The red ones, these are going to throw the scrap up on the left side of the blades as you're making a cut. The green ones are going to throw the curl up on the right side. Over here, you just want to make sure that as you're making a cut, that the curl just continues in one continuous flow like that. If it gets in its own way, you just move it and continue cutting like so. And these will do a really nice job. They're just meant to only cut about a 1/4 inch or less. So where you get into trouble is if you try to cut a really broad piece with them, and the reason for that is then the metal will not curl up because it's so stiff that you just have a really hard time making a nice cut. When you're done with your cutting, it's a good idea to take a file and run it across these surfaces just to take off any burrs, and then you're ready to start shaping. I've annealed my panel. I have it lying face down, and I put my paper pattern against the back side of the sheet metal. I left a little bit extra on every edge except the rear edge because I just want to make sure that I don't end up a little bit shy in the end. And I'm looking at where I had to cut my paper in order to get it to fit on my panel. And at all of those places where I cut the paper, I'm just going to make a line with my permanent marker. Those will be areas that I know I will need to do some shrinking, and I'll show you that next.